All right, in this video, they're asking us to find the intercepts and to graph the equations. So if we look over here at this little set of steps in green, it just describes how to find intercepts. So basically you set the opposite variable equal to 0. So if you're looking for the x-intercept, you actually set y equal to 0. But if you're looking for the y-intercept, you actually set your x equal to 0. And then you solve for the other variable, and you will get the intercept. Remember, the intercept is just where the graph crosses that axis in our rectangular coordinate system. Okay, let's look at example A then, and we'll apply the steps to do this. Basically, we're going to create a little grid here, an XY table, and we're going to go ahead and plug in 0 for x and then 0 for y. So when I put 0 in for x, I'll get the y-intercept. I'll get y is equal to 3 times 0 plus 6. Of course, 3 times 0 cancels out to just 0, and we have y is equal to positive 6. So that's your y-intercept. Let's try to solve for the x-intercept then. We need to set y equal to 0 in that case, and then we'll have 3x plus 6. Then we just solve for x, so I'll subtract 6 from both sides, and that'll give me negative 6 is equal to 3x. Then I divide both sides by 3, and I get the idea that x is equal to negative 2. So negative 2 becomes our x-intercept. All right, from here, let's go ahead and graph the graph then. So I'm going to draw a little coordinate system here. So there's my y-axis, right? My vertical axis or y-axis. And then I'll draw my corresponding x-axis. And let's go ahead and plot this set of points on the grid. Well, if x is 0 in the center and y is 6, we're going to go nowhere on the x-axis, but we're going to go 1, 2, 3, 4, 5, 6 on the y-axis and put a point there. And then for the second point, we're going to go negative 2 on the x-axis, right? So 2 out on this x-axis here. But we don't go up or down on the y-axis, we just stay at 0. So we plot the point there. And then we just basically connect the points to form the graph. We can do this with just 2 points because this graph turns out to be just a line. We can tell it's a line because both the y and the x are raised to the first power, and the structure here is just kind of a typical linear equation of y equals mx plus b. We will learn how to recognize these graphs in another section, but for now, this is a line, example A, and we can graph it with just 2 points. All right, let's do the same thing for equation B. All right, so we'll create our table, x and y, and we'll fill in 0 for x and 0 for y and see what that gives us for the other variable. So letting x be equal to 0 means we'll have y is equal to negative 0 squared plus 9. And of course, the 0 squared will just cancel out, and y is equal to 9 is our answer for that one. And for the situation where I plug 0 in for y, I'll have 0 is equal to negative x squared plus 9. And then I can just move this x squared over here, making it positive when it crosses the equal sign. So x squared is equal to 9. And then of course, I'll have to take the square root of both sides. So I'll have plus or minus the square root of 9, which is equal to plus or minus 3. All right, so you have your 2 actual answers when y is equal to 0. So you end up getting positive 3 for x and 0 for y, and then of course, negative 3 for x and 0 for y. Okay, let's go ahead and graph these points then and see what we get. Okay, so it's useful to know the general shape of the graph. So it turns out that this particular equation is going to have a graph that looks like a parabola. So the first point is 0, 9. So we're going to go nowhere on the x-axis, but up 9 on the y. So 1, 2, 3, 4, 5, 6, 7, 8, 9. So we get that point there. And then the other 2 points are 3, 0, so 3 on the x-axis, 1, 2, 3, but nowhere on the y-axis, and then negative 3 on the x-axis, negative 1, negative 2, negative 3, and nowhere on the y-axis. And again, because I happen to know that this is a parabola and it looks like it's opening down because of this negative sign here, then I'm going to go ahead and draw these dots connected like this. And that's approximately what the graph will look like. Okay. Let's go on then to do our last case, case C. In the graph, this one, we'll do, again, something very similar. We'll just basically create a table, x and y, and we'll find the intercepts by putting in 0 for x and then 0 for y. So if I let x be 0, we end up having 3 times 0 squared plus 2y is equal to 6. So of course, 3 times 0 squared cancels out. And 2 times what gives you 6? Well, the answer is 3, right? So that first one will solve to give us 3. When I let 0 be plugged in for y, I end up having 3x squared plus 2 times 0 is equal to 6. So of course that'll give you 3x squared is equal to 6. If you divide both sides by 3, you end up getting that x squared is equal to just 2. And then if you want to solve for that x, you just do x is equal to plus or minus the square root of 2. So again, we get 2 answers. One where x is the square root of 2, and one where x is negative square root of 2. And remember, the square root of 2 is approximately 1.4, right? Just for graphing purposes, we want to have some idea of what that is. All right, so let's go ahead and put that on a grid system then. And when we draw our rectangular coordinate system, we'll have our usual y-axis and x-axis. And the first point we're going to plot is 0, 3. So 0 on x-axis, but 3 on the y. 1, 2, 3. So about there. Then we have the square root of 2, 0. Square root of 2 again is like 1.4. So maybe like 1.5 here. Somewhere around there. But 0 on the y-axis. And then likewise on the other side, we'll do the same thing. We're going to go negative 1.4. So here's negative 1, and then 1.4 might be there on the negative side. And again, this is a parabola again, and again, it will open down, so we're looking for the rough shape to be something like this. Okay, so again, to graph these, you did have to assume that you had some understanding of the basic equations and their underlying graph, but if you don't know that, we'll cover that in chapter 2 as we go further along. When you come back, you'll be able to see why we were able to draw these graphs with so few points.